Okay, as we move through today's lessons, what we're going to be talking about are the 6 types of simple machines. You can see those pictured here. They are the pulley, incline plane, lever, screw, wedge, and wheel and axle. At the completion of this lesson, you should be able to do the following. You should be able to identify the 6 types of simple machines. They were just listed on the previous slide. You should be able to give an example of each of the machines used in everyday life. And finally, you should be able to calculate the ideal mechanical advantage, or IMA, for each type of simple machine. So as we get moving through here, we're going to talk about pulleys. In each case here, you can see a picture of different types of pulleys. Pulleys are wheels and axles with a groove around the outside, and passing through that groove is some type of rope, chain, or belt that will allow it to work. Okay. There are 3 types of pulley systems, and each with its mechanical advantage. We're going to start first with a fixed pulley. You can see here what a fixed pulley is. What does that mean? That means the pulley or wheel and axle portion of the pulley is set in place. It does not move. With this type of pulley system, you get a mechanical advantage of 1. What does that mean? The amount of force you have to put in is equal to the amount of force the machine does you. The advantage here then is coming in the change in direction. You pull down and this lifts up. But again, you're going to have to pull with a force equal to the weight of the object. Then we have what is called a movable pulley. Again, we're only going to consist of 1 wheel and axle, but as you can see here, the wheel of the axle is moving as the rope is pulled. Since that pulley or that wheel and axle is moving, that changes your mechanical advantage, and this gives you a mechanical advantage greater than 1. To calculate the mechanical advantage, you just simply count the number of support ropes. So, in other words, here is 1 support rope, here is a second support rope, so we have a mechanical advantage of 2. Almost all movable pulley systems have a mechanical advantage of 2. Okay, and then that leads us to our 3rd type, and that is when we combine the first 2. You can see here we have combined a fixed pulley with a movable pulley, and now we have a combined pulley. Okay, this is real simple. We count the number of wheel and axles involved. Okay, the number of wheel and axles involved. The disadvantage here is that you must pull a much longer distance. Okay, because if you remember when we talked about actual mechanical advantage and calculating work, the work in has to be equal to the work out and vice versa. So if we're going to use less force, we got to pull a longer distance. That leads us to incline planes. The most common incline plane obviously is the ramp. Okay. So basically an incline plane is any flat surface where one end has been raised higher than the other end. This makes work easier because you are going to use less force, but again, you're going to have to apply that force over a greater distance, just like you did with the combined pulley system. For example, the guy rolled the barrel up the ramp. This was much easier for him to do than try to lift the barrel directly up and on to the platform. The mechanical advantage of an inclined plane is a simple math problem, simple calculation. You simply take the length of your ramp. So if we look at this particular inclined plane, it has a length of 15 feet. And you simply divide that by its height, which in this case, this inclined plane had a height of 3 feet. So the ideal mechanical advantage is going to be 15 divided by 3, and that should give us a mechanical advantage of 5. Now again, this is ideally. We both know that's not going to be exactly right because there will be some friction between the object and the inclined plane. But in an ideal world, no friction, you should be able to apply 5 times less force. We move quickly on to the lever. And here are 3 different pictures of 3 different types of levers. Each one of them consists of the same 3 parts. we have what is called the fulcrum. That is your point of rotation. We have the effort arm. The effort arm is where you are going to apply your effort, or this is the force in. And then we have the R. The R is the load. That is the resistance. So that's the weight of the object. That's where the other object would be. The effort arm is the distance from the fulcrum to where you push, or your effort is applied. The resistance arm is the distance from the fulcrum to the object that is being lifted, or the load. Mechanical advantage is simply a ratio. A ratio means we are doing a division problem. So you measure the length of the effort arm. Again, that is the distance from the fulcrum to where you will be pulling down. And divide that by the length of the resistance arm. Okay, and that's the distance from the fulcrum to the load. So let's get into our three classes of lever. If we look here real quickly, we can see that the fulcrum is between your effort and the load. F is between E and R. You'll notice that you have to pull a longer distance. That allows you to use less force. So we multiply the effort force. We change the direction. That's the advantage. However, we do have to pull over a longer distance. Examples of these types of levers in everyday life include crowbars, scissors, pliers, tin snips, and seesaws, what we commonly call teeter-totters. As we move to our second class lever, you can see our position of our three things has changed and the fulcrum has moved out to one end. So in this case, the load is in the middle. Where you are going to apply effort is on one end, the fulcrum is on the other end. What does this do? It multiplies effort force. But in this case, you are pushing in the same direction as you are moving the load. So there is no change in direction like there was with the first class lever. Again, since you are using less force, you will apply that force over a greater distance. This is your second class lever, fulcrum, resistance, effort. Examples of these, and a couple of them were mentioned in your previous problems. We have nutcrackers, wheelbarrows, doors on its hinges actually work this way, and bottle openers work this way. They are second class levers. And then we get into our third class lever. In a third class lever, we still have the fulcrum on one end and the position of the effort and resistance has changed. Okay, so now the effort force is between the fulcrum and the load. This does not multiply the force. Okay, we actually have to use more force. Okay, so we actually have a mechanical advantage of less than 1. So why use a third class lever? This allows us to move our load over a greater distance. Okay, it multiplies the distance rather than the force. So we can move it a farther distance, and that's why we sometimes need to use third class levers. Examples: tweezers, which most of you sure. Your arms, if you place an object in your hand like you see in the picture, can act as a third class lever. Hammers can work this way, and we're talking about the claw, using the claw portion of the hammer, and shovels are examples of third class levers. After we get done with levers here, we're going to run into screws. What is a screw? A screw is actually a special type of inclined plane, but they have given it its own name. What does a screw do? It converts rotational motion, So spinning motion into linear motion or straight line motion. It does this by converting something called torque, which is a type of force, it's rotational force, into, again, linear or straight line force. So in other words, we're going to turn the screw to make it go in a straight line forward. That's what a screw does. So how do we calculate the mechanical advantage of a screw? And you can see here jar lid, drill bits, our everyday screw, things like that make for it. The IMA is simply by dividing the circumference, okay, distance across the screw, by the pitch, and the pitch is simply the distance between the threads, and you can see there in the picture above the threads. Okay, so the distance between threads is called the pitch. So we take the length across the screw divided by the distance between those threads, and we have the mechanical advantage. Wedges are our next type of simple machine. These include axes, zippers, knives. Okay, wedges also are special types of inclined planes, and in a wedge is when two inclined planes have been put back to back. Okay. These are used to split and cut things, and also in the case of the zipper, it's used to hold things in place. We could also think of a commonly used wedge as a doorstop, and that would hold the door in place. Mechanical advantage is simply dividing the length of either slope. So again, we're taking the slope of our inclined plane, and we're going to simply divide that by the thickness of the wedge, which is the letter T in this picture. Okay, so in other words, you've taken the height of each wedge, since we said it's two wedges back to back, and added them together to get our thickness. Okay, as with the inclined plane, the mechanical advantage gained by using wedge requires a corresponding increase in distance. Okay, so less force, greater distance. That is the advantage of a wedge. Finally, we have the wheel and axle. Wheel and axle, as you can see, is pictured right there. The axle is stuck rigidly to a large wheel. It is the wheel that in many cases that is rotating. To find the mechanical advantage, you simply take the radius of the wheel and compare that to the radius of the axle. So a wheel is the point here for out. The radius of the axle is right here. So again, the wheel, axle, and you're simply going to do a division problem. The wheel and axle can increase speed by applying the input force to the axle rather than the wheel. This combination would increase the speed 5 times. Okay, so that is the mechanical advantage of a wheel and axle. Some more common examples of wheel and axles include ceiling fans, as that were previous pictures, gears and their cogs, bicycle wheels, the wheel and axle on your car. And if you remember, even pulleys use wheels and axles. Okay, so those are your 6 different types of simple machines. Just watch the next video that is after that. It again will go over the 6 different types of simple machines as a review, and then you will be finished for the day. So once you have finished, have a great Thanksgiving weekend.